These more complicated ones. And what's nice about this guy here is even if you get sort of stuck on the lower sediment layer function, you can still kind of get a good chunk of the way through this guy. We can kind of start with that. We know on this guy here that they are vertically, they are aligned. The maximum and the minimums are aligned. So what that means is the peaks, the troughs, they're all aligned with each other. How that's helpful is like right off the bat, I know that that's 20. I know that that is going to, or sorry, this one's 10. And then this one's 20. Okay, so from here, we can start to kind of identify some of the aspects of both of these functions. So let's just start with the upper function, right? And identify on this guy right here, what is my maximum, what is my minimum, what is my A, and then alternately, what is my K. Additionally, we could figure out what the period is, which allows us to find the B, and then identify what our H may be given this scenario. So, first things first, the maximum I know is -5. Kind of weird that it's a negative value, but it's the highest it goes. The minimum is -10, meaning that I can figure out A by going what's the total distance between the two and divide it by 2. Well, I know that is half of 5, or in between -5 and 10 is 5 units. Divide that by 2 gives me 2.5. So then K is just me taking the maximum and then subtracting A, so -7.5 is my K value. Now, alternately, the period is found by figuring out when it repeats itself. So from peak to peak or trough to trough. Now, I know this starts at 10 and I know halfway is 20, so then I know the full distance is going to be 20. Meaning B will be equal to 2 pi divided by 20 or pi over 10. Now, the last part about this, where there's other ways to do it, but a lot of this is just kind of like logic and reasoning. So if I know that that full distance is 20, and I know that half of the way is 10, then I know a quarter of the way is 5 units. Here's where that comes into play. We want to find out what our H value is. H value starts halfway from the peak and the trough. I mean, I can easily figure out this guy, what's halfway between 10 and 20. It's 15. So then on this side of it, my H is going to be 5. And my K is going to be -7.5. So there's a little bit of reasoning work that comes into play there that makes it a bit more challenging. But now I've gone as far left as I can to grab a more accurate value when I go to solve. So I have the rule. I now know that we're trying to figure out what the distance between these two guys is. So essentially, I got to find the rule for both of these functions, plug in whatever x value gets returned for the y value of -6.25. Only thing to keep in mind, right? If I'm looking right here, okay, at that point right there, what we end up looking for in this scenario is going to return 2 values, and we now know we're going to have to take the bigger of the 2. So let's try solving for that. So this is that whole process. Find x, so a little bit more challenging, when y is equal to -6.25. So we are going to plug that in as a y value. We have 2.5 sine pi over 10 x minus 5, and not plus, but -7.5. Now, I am just going to go back and double check one thing, because if we didn't do this right, then it's going to throw everything off. When I found out what the A and the B value of these things were, what mattered more than anything was what direction was this going in from where it started. So if I started at 5 and -7.5, right, it goes up first and then down. So the A value on this guy is positive. If it went the other way, then I would have to change the way I wrote this. But it ended up working out, so we don't have to worry too much about that. Now, all that to say, we're still going to work these out the same way. Mentioned this in a previous video. We're trying to isolate for this. Theta is the combo of B, X, and H. We are trying to isolate for sine theta. So we will bring this guy over here. We'll be adding 7.5. So essentially, it's just going to be positive 1.25 is equal to 2.5 sine pi over 10 x minus 5. That didn't change. We then still divide by the negative 2.5, because we want to figure out on this guy here, he'd be positive 0.5 is equal to sine pi over 10 x minus 5. Now, I have a nice decimal there. I can't really go find that guy on the unit circle. Might be able to find him. Who knows? I can show you later on for those that are somewhat interested. But if we're sticking with the method that will work every single time, then we're going to just use our calculators now. We're going to take that 0.5 and making sure that my calculator is in radians, so it should have an R highlighted or an RAD. If you don't know what this means, then just bug me in class and I'll sort it out for you. But essentially, this next step is going to be me writing out sine minus 1 of 0.5. So shift sine 0.5. And it's going to give me something like a value of 0.524. Right? 0.524. Now again, as mentioned in a previous video, what we are using this for, this is essentially theta. We can now look to our mini sort of unit circle, the cast circle, and identify, well, what quadrants would a positive 0.524 exist in for a sine function? Well, that one would exist here and here, meaning this one's going to be straight theta, and this guy is going to end up being pi, right? Pi minus theta. Pi minus theta. To get this full angle here is kind of the idea. We only know theta as a measurement from the x-axis, so that's why we're going to go pi minus theta for that second angle, because this is the only way for us to kind of calculate it. So what that means is things are going to split off here. We're going to have pi minus 0.524 is equal to, sine now disappears, pi over 10, x minus 5. And we're going to have the easier one of just 0.524 is equal to pi over 10 x minus 5. So how does this work out now? Let's just get into our decimals, right? Figure out what these guys are. So 3.1415 minus 0.524 and have 2.6175. Go at least 3. And then pi divided by 10. Oh, shouldn't have to do that. 0.3142 x minus 5. And same thing for this guy here. 0.524 is equal to 0.3142 x minus 5. And then now we're just going to divide. This is just algebra. Okay, 0.3142. And then x minus 5 will be equal to something along the lines of 1.67. Now, I think it originally said tenths. So I'm just going to say 1.7 as a value here. And then x minus 5, bring that guy over. X will be equal to 6.7. So that'll be one of the answers. This other one, 2.6175 divided by 0.3142, gives me something like 8.3 is equal to x minus 5. Bring this guy over, x is going to be equal to 13.3. So there is a little bit of like validation checking you can do here. If I go up to it and take a look at it, just get rid of this for a second and get rid of the h value. If we zoom in and recognize that this value is 10, and I found two values, 6.7 and 13.3. Well, this is going to be the x value of 6.7, right? At negative 6.25. Let's try and draw that again. 6.7. And this one is going to be the 13.3. Why that's important is that this is the one you're going to choose to continue to use for this scenario, right? Because it's the one that's aligned with this point down here that we're going to plug in. So it was important that I was able to identify that. That's something I'm going to be looking for. So from here, I know what the y value is of this guy. I want to now figure out what the y value is of that second guy. So let's start to take a look at the lower function right now. And what are the things that we know about it? Well, we know that it has the same period, and as such, it would have the same h value as well. So I can put that in as well. So 5 and negative 30 would be that right there, because I stole the negative 30 from this right here, knowing what my k value is. And then there's this weird point. So it's showing right here that weird point. This is the situation I started to talk about at the beginning of this, in that guy, this is a unique scenario. So let's go down and write down for the lower sinusoidal function. We normally do our like max min, a, k. On this guy, we don't know, we do know that this is 30. But the rest of this would be the same. I'm not going to go through and solve that guy. And then the h is 5. So for right now, if I go to start to write out what I know, I have a sine pi over 10 x minus 5 minus 30. So I have part of this solved for. The only other thing that I have that I can include now is that 18 and negative 38.09. So let's actually just plug that in and see what happens. Pi over 10, x minus 5, minus 30. So, unique scenario. Oh, I didn't even write in what the x value was. So, sine, let's try that again. Pi over 10, 18 minus 5 minus 30. So again, it's important for us to note that this is a block and a unit that needs to be treated differently. And when I have all of the values in there, what that means is I should solve for this guy first on its own. As in negative 38.09, I'm not going to touch right now. A sine pi over 10, I'm not going to touch right now again either. 13 minus 30. Again, that block is important, and I'm not going to use or execute the sine function until 38.09a, and then what's pi divided by 10 times 13? So this is going to be something like sine 4.08, 4, if we will, 4.084 minus 30. Now you could have kicked that 30 out of the way first, right? Doesn't really matter when you do it. But at least right now, I have this ready to use. Now it's on the same side and it's right next to it. So I am literally just going to write sine 0.084 and then hit equal to. And that's going to give me something like, something wonky like negative 38.09. That didn't change. A times negative 0.809. And then minus 30. Again, I could have kicked that 30 over first. Doesn't matter when I do it. Just know that it's A times negative 0.809. So that can't interact with this 30. But I combine like terms and leave myself with negative 8.09 is equal to A times negative 0.809. And then negative 0.809, negative 0.809, and that's going to return me an A value of 10. And we can double check that given this scenario and go back all the way up to the top and identify that I have originally the upper one had an A value of 2.5. It was positive. And this one with an A value of a positive 10 makes sense because that amplitude is higher on this guy. So it's important that we know that. So now that I have that rule, okay, because I had to go through all that just to get the rule, now I'm literally just going to use this rule. So y is equal to 10 sine pi over 10 x minus 5 minus 30. Now that I have the rule, I can use the rule, and all we're going to do now is just plug in a value for x. What is that value for x? That's the 13.3 that we found earlier. So now we can just solve for what is that y value, right, when x is 13.3. And again, solving for y is always easier, right? Hopefully that's sunk in by now. But my suggestion, as always, we treat this differently. So 13.3 minus 5. And I'm going to multiply. So I'll just write this out. Might as well be clear with this. 10 sine pi over 10, 8.3 minus 30. And I'm going to multiply that 8.3 by pi over 10. So that's going to return y is equal to 10 sine 2.607 minus 30. Now that I have a singular number next to sine, I can write sine 2.607. And then whatever I get returned in radians there. 10 times 0.509 minus 30. So essentially y is equal to 5.09 minus 30. So in this instance, we're going to have y value of 24 or negative 24.9, let's just say, in this instance. And so now let's go back up to it. The two functions, right? Looking something like this. This isn't perfect at all. I think it was actually like on this side of it kind of thing and right here. So this had a y value of negative 6.25, and this has a y value of negative 24.9. So we're just going to find the difference between those two values and get something along the lines of 18.65. So that would be the total distance between the two. Because we'd be subtracting them from one another. So quite a challenging problem, but unique in terms of solving for the a value here to find the rule. Not something we've seen before. Next up is cosine functions.